Welcome to qnawire.
This question gives you a ball going to the right or a tennis ball traveling at 50 meters per second. And then it gets hit by a racket and then it goes in the other direction at 40 meters per second. And you want to calculate first thing the impulse that this racket supplies to make this kind of motion happen, and then you also want to calculate the work done by the racket or the work supplied by the racket to the ball. So the first thing I want to do is calculate the impulse. So we know again from the chapter that the impulse is equal to the change in momentum for the system. So we know that the change in momentum is just the mass. In this case, because the mass is not changing, we have some kind of final velocity minus the initial velocity. So this will give you the change in momentum. So we know the mass, which was 0.06 kilograms, and the final velocity in this case was 40 meters per second. But in this case, we can assume that positive is to the left here. So this is positive 50, this becomes negative 40. So this would actually be a negative final velocity in this case. You can do it in the opposite direction where you assume left is positive, but that will just give you a negative answer for your change in momentum. And then the initial velocity in this case was 50, positive 50. So just subtract the initial velocity. And then what you get once you do this math is that the actual change in momentum, which is equal to the impulse, is 5.4 Newton seconds. In this case, it's negative sign because this impulse was in the direction of the final velocity. So now, once you finish with the impulse, then now you can start thinking about the work. So in order to calculate the work, you do the work energy theorem that says the net work done on the system is equal to the change in kinetic energy, change in potential energy, and all that. But since in this case, this motion is all horizontal, the net work is just going to be equal to the change in kinetic energy for this ball. And the change in kinetic energy we know is just going to be half m, again, the velocity final squared minus velocity initial squared. So once you do this calculation now, you know the mass, you know the final velocity, which is negative 40 meters per second, but if you square that, it just becomes positive. And then here you have initial velocity squared, which is 50. So 50 squared, and you find that the net result that you get is about 27.0 joules of energy supplied in this case. So you'll notice that this number is bigger than this number, so you get negative value, which means that this is the work that the racket is doing on the ball, and so that should be opposite of the work that the ball does on the racket.